For as long as we have tried to understand ourselves, one question has echoed through classrooms, conversations, and the deepest corners of human curiosity. Did we come from monkeys? It sounds simple, almost childlike, yet the truth behind it is far older and far stranger than most people ever imagine. The famous illustration that shows a hunched ape slowly rising into a modern human appears in school books and on countless shirts, but it is one of the most misleading images in the history of science. Our story is not a straight line. It is a vast and tangled tree filled with hidden branches, forgotten relatives, and entire worlds that disappeared long before our species ever appeared. To understand who we are, we must turn away from the comforting symbols and step into the deep past, into a darkness older than deserts and older than the mountains themselves. Every step back in time feels like brushing away dust from a long buried secret, and the farther we travel, the more the simple question begins to unravel. We did not come from the monkeys that walk the earth today. Instead, we share roots with them. The answer is not yes or no. It is a story woven from survival, extinction, and chance. So let us begin this journey together, not toward the stars, but back into the ancient forests and shifting landscapes that shaped our destiny. As we trace the forgotten paths of our ancestors, we will discover a truth far more incredible than any simple picture on a page. This is the story of how we truly came to be. To understand where our story truly begins, we must step even deeper into time, far beyond the first humans, and far beyond the ancestors whose bones we can hold in our hands. We must return to an age when the world was ruled not by us, but by the great ape families that once covered Africa like a living canopy. It was the late Miocene, a period more than 7 million years in the past, when the continent was warmer, greener, and more stable than it is today. Forests stretched from horizon to horizon, and more than 100 different species of apes swung through the branches. Today, only a small handful remain, the survivors of a world that has almost completely vanished. Somewhere among those ancient forests lived a creature we know only through the echoes it left behind. Scientists call it the last common ancestor, yet no fossil confirms its face or its form. It is a shadow on our family tree, a being that was neither human nor chimpanzee, but something in between, something lost to time. We know it existed because our DNA remembers it, because the branches of our genetic story converge on a single point deep in the past. This ancestor was not a modern monkey, and it was not a modern ape. It was a species adapted to climbing, grasping, and living safely in the dense forest that once blanketed the continent. But the world began to change. Beneath the surface of Africa, colossal tectonic forces pushed and pulled at the land. The crust stretched open, creating what would become the Great Rift Valley, a scar that can still be seen from space. As the land tore apart, the climate shifted. Rain patterns collapsed on the eastern side of the continent, forests shrank, and grasslands, known as C4 savannas, spread across the drying earth. What had once been an endless green world turned into a patchwork of shrinking trees and expanding plains. For the apes that depended on the forest, this was a disaster. But for a few populations living near the new savannas, it became the beginning of something extraordinary. Separated by geography, challenged by hunger, and pushed by the changing landscape, these early ape populations began to diverge. One branch would eventually lead to modern chimpanzees and bonobos. The other would set foot on a path that no other creature would ever walk, a path that leads, step by step, to us. As the forests continued to retreat and the savanna spread across the land, the descendants of that ancient ancestor faced a choice written not in thought but in instinct: survive by adapting, or vanish like countless species before them. It was in this unstable and unpredictable world that one of the greatest turning points in our entire evolutionary history quietly began. Long before our ancestors made tools, long before fire illuminated the night, they stood up. The earliest clues come from a being known as Sahelanthropus, discovered in the heart of Africa. Its skull carried a secret at the base, a small opening called the foramen magnum. In creatures that walk on all fours, this opening is angled toward the back of the skull, but in Sahelanthropus it shifted downward, suggesting that its head balanced above a vertical spine. It was one of the earliest signs that an ancient ape was learning to walk upright. But Sahelanthropus was not alone. In the hills of Kenya, another early pioneer left behind fragments of its legs. Orrorin, sometimes called the original man, had a femur shaped in a way that hints at both climbing and upright walking. These early ancestors were not fully committed to the ground. They still relied on the safety of the trees, yet the savanna demanded a new posture, a new way to move, and perhaps even new strategies to survive. Then came a creature unlike any we expected. In the woodlands of Ethiopia lived Ardipithecus, known as Ardi, a being that shattered the long-held idea that walking upright evolved only in open grasslands. Ardi lived in forests, yet its pelvis and its oddly shaped foot suggest a form of cautious bipedalism. With a grasping big toe for climbing and a pelvis built for balancing upright, Ardi revealed that the story of walking on two legs was far more complex than a simple shift from forest to savanna. Why did this change happen? Scientists believe there was not just one reason, but many. Walking upright reduced the amount of heat absorbed from the relentless sun. It used less energy than moving on all fours. It allowed arms to carry food and infants to safer places. It even helped early ancestors throw stones or branches to intimidate predators. Every small advantage mattered in a world filled with danger. And so, step by unsteady step, these early species set humanity on a new course. It was not a dramatic leap, but a slow transformation unfolding over millions of years. Yet it was enough to separate one branch of the ancient ape family and place it on a path no other creature would ever follow. As millions of years passed, the early experiments of evolution gave rise to a new and remarkable group of beings. They were neither ape nor human, but something caught in between, something balanced on the edge of two different worlds. These were the Australopithecines, the ancestors who would carry the story of bipedalism forward and reshape it with every step they took. Among them, one individual would become a symbol of our ancient journey. She is known to us as Lucy. Lucy lived more than 3 million years ago in the shifting landscapes of East Africa, where forests and open plains existed side by side. Her body told an extraordinary story. From the waist down, she moved like a modern human. Her pelvis was broad and low, shaped for balancing her body over two legs. Her femurs angled inward toward her knees, showing that she walked with a long, confident stride. Yet from the waist up, she still held on to the past. Her arms were long and strong, her fingers curved for gripping branches. She lived a hybrid life, walking upright on the ground but climbing high into the trees to gather fruit, to sleep safely, and to escape predators that stalked the plains. The most vivid proof of her kind did not come from her bones alone, but from footsteps left in volcanic ash in what is now Tanzania. The Laetoli footprints, preserved for nearly 4 million years, showed 2 or maybe 3 individuals walking side by side, leaving a trail that looks almost modern. Heel first, then the push of the toe, a steady rhythm across soft ground. These were the first footsteps of a family that would someday become us. But Lucy was only one of many. Across the continent, other species of Australopithecus were carving their own paths through the ancient world. Australopithecus africanus lived further south and showed even more human-like traits in its skull and body. Australopithecus sediba, discovered in South Africa, carried an astonishing mix of features. Its hands hint at the ability to manipulate objects with surprising precision, and its pelvis shows early signs of the changes that would define the human genus. Some scientists believe Sediba may sit very close to the moment when Australopithecus began to transform into something new. Then there was Australopithecus gahi, whose name means surprise. Found with animal bones marked by sharp cuts, this species may have been among the first to experiment with simple tools, long before stone flakes were intentionally shaped. Together, these species reveal a world filled with diversity, a world in which many branches of our lineage were exploring different solutions to the same challenges of survival. But the environment continued to shift, becoming drier, harsher, and less forgiving. The old ways of life, based on plants, fruits, and tree shelter, were no longer enough. The world was changing, and so too would our ancestors. Around 2.5 million years ago, a new kind of being emerged from the patchwork savannas and river valleys of East Africa. This was the first member of our own genus. This was Homo habilis. Homo habilis was small by modern standards, but its mind was taking a decisive step forward. Its brain was larger than any Australopithecus before it, crossing the threshold of 600 cubic centimeters. But the most important change was not in the skull. It was in the hands. For the first time, our ancestors intentionally shaped stone. The Oldowan tools they created were simple, but they were revolutionary. By striking flakes from river cobbles, they produced sharp edges capable of cutting into flesh, tendons, and hide. With heavier cores, they smashed open bones to release the precious marrow hidden inside. This shift changed everything. For the first time, early humans gained access to a rich supply of calories and fat that no ape had ever used so efficiently. This new source of energy fed their growing brains and fueled a cycle of adaptation that would continue for millions of years. Bigger brains allowed more complex thinking. More complex thinking allowed better tools. Better tools opened new ecosystems and new opportunities for survival. Homo habilis likely lived in small groups, spreading across the landscape in search of carcasses left behind by predators. Within these groups, there may have been early forms of cooperation. Some stood watch while others worked to break bones. Some carried food back to safer areas. Even simple communication, possibly through calls that distinguished danger the way modern vervet monkeys do, could have shaped their chances of survival. They were still vulnerable. They were not yet masters of the landscape, but they were becoming something different, something no other species on Earth had ever been before. They were thinkers, planners, and problem solvers, and with each tool they shaped, they took one more step toward becoming human. As the world continued to shift and the challenges of survival grew sharper, the lineage shaped by simple stone tools and growing intelligence evolved once again. From the ancient landscapes of Africa emerged a species unlike any that had come before. Taller, stronger, and far more capable, this new being would carry our story across continents. Its name was Homo erectus. Homo erectus appeared nearly 2 million years ago and would endure for an astonishing span of time, far longer than our own species has existed. Their bodies were transformed for life on the open plains. Long legs and shorter arms meant they moved with an efficient stride. Their chests were broad and their skeletons sturdy. For the first time, a hominin walked with a form that fully resembled a modern human from a distance. But it was not just their appearance that set them apart. It was their endurance. Unlike the predators that relied on short bursts of speed, Homo erectus mastered the art of persistence hunting. With the ability to sweat across almost their entire body, they could release heat faster than any other mammal. This meant they could chase prey mile after mile under the burning sun until the animal collapsed from exhaustion. It was a hunting strategy that no ape had ever used, and one that opened a new world of nutritional possibilities. Their minds were also advancing. The stone tools of Homo erectus were no longer simple flakes. They crafted large and elegant hand axes shaped like teardrops, tools symmetrical and deliberate, revealing planning and a growing sense of design. These Acheulean tools were not the work of instinct. They were created through thought and practice, passed down through generations. But perhaps the greatest transformation was their relationship with fire. In caves such as Wonderwork in South Africa, ash and burned bone appear in layers that prove fire was not accidental. It was tended, controlled, and used. Fire changed everything. It provided warmth in cold nights, protection from predators, a gathering place for social bonds, and most importantly, cooked food. Cooking unlocked calories that raw food could never provide, shrinking the time spent chewing and expanding the energy available for the ever-growing brain. Armed with endurance, intelligence, and fire, Homo erectus became the first human to leave Africa. They spread into Asia, the Middle East, and Europe, adapting to new environments with remarkable resilience. They were no longer creatures bound to a single landscape. They were travelers, pioneers, and the first true global humans. Their footsteps paved the way for every species of human that would follow, including our own. Yet even as Homo erectus spread across continents, the human family tree was becoming more tangled than ever before. New branches emerged, each one adapting to its own isolated world. In the dark chambers of South Africa lived Homo naledi, a small-bodied species with a surprisingly complex brain structure. Far to the east on the island of Flores lived Homo floresiensis, a species so tiny it was later nicknamed the Hobbit, shaped by the mysterious forces of island evolution. In the Philippines, another small and ancient species appeared, known as Homo luzonensis, and deep in the frozen landscapes of Siberia, the Denisovans thrived, their identity revealed only through fragments of bone and the silent memory written into our DNA. These were not failed experiments. They were different solutions to the same question of survival, branches of our family that existed alongside our ancestors for thousands of years. But in the end, only one branch would remain. Our species, Homo sapiens, would inherit a world shaped by countless others, a world carved by the footsteps, fires, and struggles of those who came before us. When we ask whether humans came from monkeys, we miss the deeper truth. We came from a long line of beings who adapted, endured, and changed with every shift of the earth beneath their feet. Our path was never a straight road. It was a maze of beginnings and endings, of triumphs and extinctions. And yet, through all of this, our ancestors carried forward the same spark, the spark to learn, to imagine, and to survive. Their choices shaped our existence. Their risks became our abilities. Their journey became our story. So as we look back across millions of years, we find not a simple answer, but a magnificent saga, a reminder that we are the last survivors of a family far larger than we ever imagined. And our story is still unfolding, waiting for those willing to explore the ancient worlds that shaped us.